There is a moment, perhaps more than any other, that would make Mars feel real. Not the moment a spacecraft touches the ground, not the moment the first human steps onto the surface, but the first night. The first time you are lying quietly inside a small habitat and realize that everything keeping you alive has been built by human hands. Outside the window, Mars is waiting. A vast red landscape stretching into the darkness. No forests, no oceans, no cities glowing in the distance. No familiar sounds of wind moving through trees. Only a silent world beneath a dark sky. And somewhere inside that small habitat, a handful of people are breathing. The air around them is warm. The pressure is carefully controlled. Water is being recycled. Machines are monitoring temperatures. Pumps are moving air through filters. Systems are checking oxygen levels. Every few seconds, something quietly turns on, or turns off, or measures something, or keeps something else from failing. It would almost feel ordinary. And that might be the strangest part. Inside the habitat, you could sit down, you could make a meal, you could speak with someone beside you, you could close your eyes. For a few moments, you might even forget where you are, until you look through the window and see Mars. The landscape would appear enormous. Mars is a world of deserts, plains, mountains, valleys, and ancient geological scars. Its surface has been shaped over billions of years. There are places where enormous volcanoes once rose above the surrounding terrain. There are vast canyons stretching across the planet. There are regions covered in dust, rock, and frozen water. But from inside the habitat, all of that beauty would come with an uncomfortable realization. You cannot simply walk outside. The window may look like an ordinary window, but it is actually part of a life support system. The wall between you and Mars is not simply a wall. It is the difference between being alive and being exposed to an environment the human body cannot survive in. On Earth, we rarely think about the air around us. It is everywhere. We breathe without asking where the next breath will come from. We walk outside without calculating the pressure of the atmosphere. We sleep without wondering whether the air will still be there when we wake. Mars would make all of that visible. Air would become infrastructure. Water would become infrastructure. Energy would become infrastructure. Even warmth would become infrastructure. Everything that Earth provides freely, Mars would demand that we provide for ourselves. And that leads to the question at the heart of our journey. Could we really live there? Not visit, not land for a few days, not spend a few months inside a carefully prepared mission, but actually live there. Could human beings wake up on Mars, go to sleep on Mars, raise families on Mars, grow food on Mars, repair machines on Mars, build homes on Mars, and eventually think of Mars, not as another planet, but as home? Because visiting Mars and living on Mars are two very different things. A visitor can arrive with everything already prepared. Food can be brought from Earth. Spare parts can be packed into a spacecraft. Medical supplies can be carried along. The mission can have an end date. There is always a plan to return. A settlement would be different. A settlement would need to continue, and continuing is much harder than arriving. Imagine the first explorers. They might spend months traveling through space before reaching Mars. When they finally arrive, the planet would not welcome them. There would be no atmosphere waiting for them, no breathable air, no forests producing oxygen, no rivers flowing across the landscape, no natural shelter. They would step out of their spacecraft wearing a suit and immediately become dependent on it. Their suit would provide pressure. It would regulate temperature. It would supply oxygen. It would remove carbon dioxide. It would protect them from the surrounding environment. Every step outside would be taken inside a small artificial piece of Earth. And perhaps that is the best way to understand Mars. Not as a place where humans simply need to adapt themselves, but as a place where humans would need to carry a small piece of Earth with them. A pocket of pressure, a pocket of warmth, a pocket of breathable air, a pocket of life. Inside the habitat, that pocket could become larger. A room, then several rooms, then perhaps an entire building. One day, perhaps an entire settlement. But outside, Mars would remain Mars. The difference between Earth and Mars is not merely that one is colder or that one is farther away. The difference is much deeper. Earth is a world where human life fits naturally into the environment. Mars is a world where almost every part of human life would need to be constructed. On Earth, you step outside. On Mars, you prepare to step outside. On Earth, you open a door. On Mars, you may need to pass through multiple sealed doors. On Earth, you drink water. On Mars, someone had to find it, extract it, purify it, and make sure none of it was wasted. On Earth, you breathe. On Mars, a machine has to help you breathe. That difference would shape everything. It would shape architecture, agriculture, medicine, daily routines, relationships, work, sleep, even the way people think about time. Because when your survival depends on systems, you become aware of things that Earth allows you to ignore. A small leak matters. A broken pump matters. A damaged filter matters. A power failure matters. A malfunctioning valve matters. A mistake that would be insignificant on Earth could become serious on Mars. And yet, there is something deeply human about the idea. We have always built shelters. We built homes against the cold, walls against storms, roofs against rain, ships against oceans, submarines against the pressure of the deep, spacecraft against the vacuum. Mars would simply be another step in that ancient tradition. Only this time, the environment outside would be an entire planet. The first habitat on Mars might be very small, perhaps a few connected modules, a laboratory, a sleeping area, a storage room, a greenhouse, a power system, a communications system, everything carefully arranged, everything with a purpose. There would be very little wasted space. Because every kilogram transported from Earth would require enormous amounts of energy. Every piece of equipment would need to justify its journey. And perhaps, after the first excitement faded, the first settlers would begin to notice something else. Mars is quiet. Very quiet. There are no cities beyond the horizon, no distant headlights, no aircraft crossing the sky, no sound of traffic, no neighbors living in houses a few streets away. The settlement might be surrounded by hundreds of kilometers of empty landscape. The nearest human being could be only a few meters away, inside the same habitat. And the nearest human world, Earth, would be millions of kilometers away. At certain times, Mars and Earth are relatively close together. At other times, they are separated by much greater distances. The communication delay changes with their positions. A message sent from Mars cannot arrive instantly. There is always a delay. Even a simple conversation becomes difficult. You speak, and then you wait. The person on Earth answers, and then you wait again. The natural rhythm of conversation disappears. The distance between the planets becomes part of everyday life. And if you looked through a window at the right moment, you might see Earth in the sky, not as the enormous blue world we know, not as the place filled with oceans and continents, cities, forests, and billions of people. From Mars, Earth would be a distant point of light, a tiny world hanging in the darkness, the place where every human being you have ever known was born, the place where every human story began. Imagine looking at that point. After living on Mars for years, perhaps you would feel homesick. Perhaps you would feel proud. Perhaps both. Because Mars might become familiar. You might know the paths around your habitat. You might recognize distant hills. You might know when dust storms are approaching. You might have a favorite place to watch the sunset. You might have memories there. Friends, family, a life. And yet, somewhere beyond that red horizon would always be the world that made you. This is where the difference between visiting Mars and calling Mars home becomes profound. A visitor thinks about survival. A resident thinks about tomorrow. A visitor asks, "How long can we stay?" A resident asks, "What should we build next?" A visitor counts the days until departure. A resident begins counting generations. And that is where the real difficulty begins. Because surviving on Mars for a mission is one problem, building a life there is another. The first people may arrive with technology from Earth, but eventually, they would need to produce more of what they consume. They would need to recycle water, recover oxygen, generate energy, grow food, repair equipment, manufacture tools, treat illnesses, build shelters, train new generations, and perhaps most importantly, they would need to learn how to survive when something unexpected happens. Because Mars does not need to destroy a settlement dramatically. It only needs one important system to fail, and for the settlement to be unable to repair it. That is why the story of Mars is not really a story about courage. It is a story about reliability. A civilization on Mars would need systems that work again and again for years, then decades, then generations. It would need redundancy, backups, stored materials, local manufacturing, knowledge, people with different skills, and the ability to solve problems without waiting for Earth. At first, Mars would still be connected to Earth. Every shipment would come from home. Every major decision might involve people on another planet. Every important piece of equipment might have been designed somewhere millions of kilometers away. But slowly, if the settlement survived, that relationship could begin to change. A habitat could become a base. A base could become a community. A community could become a settlement. And perhaps, after generations, something entirely new could emerge. A society that no longer remembers Mars as a place they traveled to. A society that remembers it as the place where they were born. For those people, Earth might become the distant world, the blue planet from old photographs, the place their ancestors came from, a world they may have heard about, but never touched. That possibility is both beautiful and unsettling, because Mars would never become Earth. Not completely. Its sky would remain different. Its gravity would remain lower. Its atmosphere would remain thin. Its landscape would remain cold and dry. And the red horizon would always remind its inhabitants that they were living somewhere humanity did not evolve to live. Yet perhaps a home does not have to be a place that was made for you. Perhaps a home can be a place where you build a life, a place where you wake up, where you know the landscape, where you remember yesterday, where you imagine tomorrow, and where someone else, perhaps a child, can someday say, "This is where I belong." So tonight, as we imagine that first night on Mars, we should not picture a grand city, not towers, not thousands of people, not a second Earth. Picture something much smaller, a little habitat, a handful of people, a few machines humming quietly in the darkness. A thin layer of glass separating human life from the Martian night. Inside, warmth, light, breath. Outside, cold, dust, silence. And beyond the horizon, a world that has been waiting for billions of years. Perhaps the first human home on Mars would look almost fragile, a tiny island of life, surrounded by an enormous ocean of emptiness. But every civilization begins somewhere. Sometimes it begins with a city, sometimes with a village, and perhaps one day it could begin with a small, pressurized room on a distant world, a room where someone looks through a window, sees the red landscape, and quietly realizes they are home. But before that can happen, we have to understand the world outside, because the moment we leave the habitat, Mars stops being a distant landscape. It becomes the environment itself, and everything about it, from the air above us to the ground beneath our feet, will remind us just how different this world really is. For a little while, the habitat can feel like home. Warm air, soft lights, a place to sleep, a place to eat, a place where the machines quietly keep watch while everyone rests. But eventually, someone has to go outside. Perhaps there is a piece of equipment that needs repair. Perhaps a sample needs to be collected. Perhaps another habitat is being constructed a short distance away. Or perhaps, for the first time, someone simply wants to stand on the surface of Mars. The door closes behind them. The pressure changes. The systems inside the airlock begin preparing the suit. And then, the outer door opens. For a moment, there is nothing between the human being and another planet. No glass, no walls, no Earth beneath their feet. Only Mars. The first thing that would become obvious is the atmosphere. Mars does have an atmosphere, but it is extraordinarily thin compared with Earth's. The pressure at the surface is less than 1% of Earth's average sea level pressure. To a human being, that is not remotely enough. You could not simply step outside and breathe. There would not be enough pressure to keep your body functioning normally. The air itself would also contain far too little oxygen for human respiration. So the spacesuit is not optional. It is part of the environment that allows a human body to exist there at all. On Earth, we tend to think of air as something invisible and weightless. But the atmosphere is an enormous physical system. It presses against us. It surrounds us. It carries heat. It moves water. It protects the surface from certain forms of radiation. And it makes liquid water possible across much of our planet. Mars has lost most of the thick atmosphere it once had. What remains is a thin envelope of gas, barely clinging to the planet. The Martian atmosphere is composed mostly of carbon dioxide. There is also a small amount of nitrogen, argon, and other gases. But for humans, the important fact is much simpler. There is no breathable air. Every breath taken outside must come from somewhere else, from a tank, from a life support system, from technology. That means the boundary between life and death on Mars would be incredibly clear. Inside the suit, you have pressure, oxygen, temperature control, protection. Outside the suit, the environment is immediately hostile. A small tear, a damaged seal, a serious equipment failure could become an emergency. And then there is the cold. Mars is a cold world. Its average surface temperature is far below the freezing point of water. But the average number only tells part of the story. Temperatures can vary dramatically depending on location, time of day, season, and local conditions. Near the equator, during the daytime, the surface can become relatively mild compared with the Martian night. But after sunset, temperatures can fall sharply. Imagine standing outside your habitat during the evening. The sun has disappeared. The red landscape is becoming darker. The temperature is dropping, and the suit around you is working continuously, keeping your body within a narrow range where life is possible. The cold would not simply be uncomfortable. It would be another environmental problem that every human system would need to manage. Then there is gravity. Mars has only about 38% of Earth's surface gravity. You would weigh much less. A person who weighs 100 kilograms on Earth would experience a weight equivalent to roughly 38 kilograms on Mars. But your body would still have the same mass. You would still have the same inertia. You would still need to move your body, and the way you move would feel different. A simple step could become a strange experience. You might be able to jump higher. You might remain in the air longer, Walking could feel lighter. Carrying heavy equipment could become easier in some ways. But lower gravity is not simply a convenient advantage. For the human body, it creates serious questions. Our bodies evolved under Earth's gravity. Our bones developed under constant mechanical loading. Our muscles developed to move against Earth's gravitational pull. Our cardiovascular systems developed to circulate blood in a one-gravity environment. Mars would change that. And we still do not know exactly what decades or generations of life under Martian gravity would do to human development. But even before worrying about the human body, there is another problem: dust. Mars is covered in it. Fine particles can be lifted by winds and transported across enormous distances. Sometimes, those winds can create dust storms, and under certain conditions, dust can spread across much of the planet. A Martian dust storm is not necessarily a wall of sand racing across the landscape like something from a movie. The atmosphere is too thin for that kind of Earth-like storm behavior. But dust can still become a major problem. It can reduce the amount of sunlight reaching the surface. It can settle on equipment. It can interfere with solar power systems. And it can make an already difficult environment even more difficult. For a settlement that depends on solar panels, dust would be more than a nuisance. It could become a resource problem. If less sunlight reaches the panels, less electrical energy is produced. If the panels become covered in dust, someone or something may need to clean them. And if a large dust storm lasts for a long time, the settlement needs enough stored energy to continue operating. This is one of the recurring themes of life on Mars. The environment does not need to be dramatic to be dangerous. Small difficulties can accumulate. A little less sunlight, a little less energy, a damaged component, a delayed shipment, a broken filter, a leaking pipe, a medical emergency. Individually, each problem might be manageable. Together, they could become much more serious. And then there is the wind. Mars has winds, but because its atmosphere is so thin, the force of those winds is much weaker than you might imagine from their speed alone. A Martian wind could move dust, yet it would not push against your body in the same way a strong Earth storm would. Still, the wind is capable of transporting dust across the surface, and over time, that dust can find its way into almost everything. Imagine returning to the habitat after a long walk. You enter the airlock. The outer door closes. The pressure begins to rise, and suddenly you are aware of the dust covering your suit. It is not just dirt. It is a material that has come from another world. Fine particles that have been sitting on the Martian surface for enormous lengths of time. The settlement would need ways to keep that dust outside, because once dust enters a habitat, it can become a serious engineering problem. It can settle on machinery. It can contaminate working areas. It can enter filters. It can interfere with moving parts. And depending on its chemical composition, some Martian dust could also raise concerns for human health if it were allowed to enter living spaces. So, even something as simple as walking outside would become a carefully controlled process. You would put on the suit, check the seals, Check the oxygen supply. Check communications. Check the power system. Check the temperature control. Check the equipment. And only then, open the door. These are underground structures formed by ancient volcanic activity. Some could potentially provide naturally shielded spaces. Imagine walking through a tunnel beneath Mars. The surface above you might be completely invisible. There could be meters of rock between you and the sky. Inside, lights illuminate the walls. Machines circulate air. Water flows through pipes. Plants grow beneath artificial lighting. People move quietly between different sections of the settlement. And above them, Mars continues its silent rotation. A subterranean habitat could feel strange at first. There might be no ordinary windows, no direct sunlight, no view of the horizon. The residents would need artificial environments to provide light cycles. Perhaps simulated dawn. Perhaps simulated sunset. Perhaps gardens designed specifically to give people a sense of openness. Because humans do not simply need physical survival. We need psychological comfort. A place where we can relax. A place where we can see something beautiful. A place that feels larger than a machine. A place that feels like home. This becomes especially important when we consider dust. Mars is covered in fine dust, and that dust can travel everywhere. A person returning from outside could bring particles into the airlock. Vehicles could carry dust into work areas. Wind could deposit it around entrances. Machines could become coated. Filters could become clogged. The settlement would therefore need carefully designed transitions between the outside and the living environment. Perhaps multiple airlocks, specialized cleaning systems, separate areas for spacesuits, dedicated maintenance rooms. The objective would be simple: keep Mars outside while allowing humans to move through it. And perhaps every person would develop a routine. Before leaving, check the suit, check oxygen, check power, check communications, check the route, check the weather, check the equipment. Before entering, remove dust, inspect the suit, seal the outer door, wait, pressurize, then open the inner door. A simple journey could become a ritual, something people perform so often that it eventually feels ordinary. Just as we lock the door of a house, or check whether we have our keys, Martian settlers might develop their own habits. Habits built around the knowledge that outside there is no room for carelessness. But even the best routine cannot prevent every emergency. Someone could become injured. A pressure seal could fail. A power system could shut down. A fire could start inside the habitat. A communication system could stop working. A storm could arrive unexpectedly. A critical machine could break. That means the settlement would need emergency systems, emergency oxygen, backup batteries, fire suppression, independent shelters, medical equipment, manual controls, spare parts, and, most importantly, people trained to respond. Imagine a warning sounding in the middle of the night. A pressure sensor has detected a problem. The lights change. People wake up. The habitat systems begin isolating the affected section. Doors close automatically. Backup systems activate. The people inside move according to procedures they have practiced many times. There would be no time to invent a solution from scratch. The solution would need to already exist. That is another difference between living on Earth and living on Mars. Earth gives us enormous margins for error. Mars gives us very little. A good habitat, therefore, would not depend on perfect people. It would depend on good systems, clear procedures, and repeated preparations. Over time, the settlement could become increasingly sophisticated. The first habitats might be small. Then, larger modules could be added. Laboratories, workshops, greenhouses, storage areas, medical facilities, sleeping quarters, recreation spaces, eventually, perhaps underground corridors, could connect them all. At some point, people might stop describing the settlement as a collection of habitats. They might simply call it a town. But there would still be a strange truth beneath everything. The town would exist inside an artificial environment. Every wall would separate human life from the Martian surface. Every window would be a carefully engineered barrier. Every breath would pass through machinery. Every drop of water would belong to a cycle. Every kilowatt of energy would have a purpose. That might make people appreciate Earth in ways we can barely imagine. Imagine returning from a long day of work inside a Martian suit. You remove your helmet. You step into the habitat. Warm air surrounds you. You hear the quiet sound of ventilation. Someone is preparing food. A light is glowing above a table. Perhaps a small plant is growing nearby. You sit down and take a normal breath. On Earth, that moment would mean almost nothing. On Mars, it could mean everything, because every ordinary comfort would be the result of thousands of decisions. Machines, systems, and people working together. And perhaps that is what a home really becomes. Not merely a place that protects you from the outside, but a place that allows ordinary life to continue. A place where you can forget, for a few moments, that you are living on another planet. You could read a book, listen to music, talk with friends, watch the sunset through a window, grow something green, prepare a meal, sleep, dream, wake up, and then look outside. Mars would still be there. The settlement might eventually contain rooms designed specifically for beauty. Large observation windows, gardens, artificial skies, open communal spaces, places where people could gather without thinking about oxygen generators or pressure readings. Because if humans are going to stay, they cannot spend every moment thinking about survival. At some point, life has to become life. Children would need places to play. Adults would need places to rest. Scientists would need places to work. Families would need privacy. Communities would need shared spaces. People would need art, music, stories, celebrations, memories. And that is where the meaning of a habitat changes. A shelter keeps you alive. A home gives you somewhere to live. The first settlers would need the first. But if humanity ever hopes to remain on Mars for generations, they would eventually need the second. Yet even the safest habitat would still face one enormous challenge. People cannot survive on stored supplies forever. Food has to come from somewhere. A settlement can bring meals from Earth. For a while. But if Mars is ever going to become a permanent home, something much more ambitious will have to happen. People will need to grow food. They will need to create living ecosystems inside a world where almost nothing grows naturally. And perhaps one of the most important moments in the history of Mars would be the day someone sits down and eats the first meal grown entirely on another planet. For a while, a Martian settlement could depend almost entirely on Earth. Food could arrive with every new mission. Packages could be carefully stored. Meals could be rationed. Supplies could be counted. And as long as spacecraft continued traveling between the planets, the settlement could remain connected to the world where everything began. But that cannot continue forever. If Mars is ever going to become a permanent home, people will need to grow food there, not just as an experiment, not just to see whether a plant can survive, but because one day, someone will need to sit down at a table and eat something that was grown on Mars. At first, that meal might be very simple. A few leaves, perhaps some vegetables, maybe a small crop grown inside a carefully controlled greenhouse. It might not look important, but imagine what it would mean. For the first time, a human being would be eating food that did not begin its journey on Earth. The seed may have come from Earth. The equipment may have come from Earth. The knowledge may have come from Earth. But the plant itself would have grown beneath the Martian sky. That would represent a subtle change. Until then, Mars would still be a place where humans survive because Earth sends them what they need. After that, Mars would begin giving something back. A small amount of food, a small amount of biological production, a small piece of independence. But growing plants on Mars would not be as simple as putting seeds into the ground. The Martian surface is not farmland. The soil is not ordinary Earth soil. And the environment outside is not suitable for most familiar plants. What we casually call Martian soil is more accurately described as regolith. It is a mixture of dust, sand, broken rock, and other materials created by billions of years of geological processes. It does contain useful minerals, but it does not contain the rich biological ecosystem that exists in healthy agricultural soil on Earth. On Earth, soil is alive. It contains microorganisms, organic matter, fungi, bacteria, nutrients, complex chemical interactions. A handful of fertile soil can contain an entire microscopic community. Mars does not naturally provide that kind of agricultural environment. And there is another problem. Some Martian regolith contains compounds called perchlorates. These chemicals are potentially harmful to humans and could complicate agriculture. So simply taking Martian soil, placing it inside a greenhouse, and planting seeds would not be enough. The material would need to be carefully processed and managed. This is why early Martian agriculture would probably take place in controlled environments, greenhouses, growth chambers, hydroponic systems, aeroponic systems, or other forms of agriculture where plants receive carefully measured amounts of water and nutrients. Imagine entering one of these growing areas. The rest of the settlement is surrounded by red dust, but inside, everything is green. Leaves rise beneath artificial lights. Water moves through pipes. Sensors monitor temperature and humidity. Roots grow in carefully managed systems. The air contains exactly what the plants need. It could become one of the most beautiful places on Mars. Outside, an ancient desert. Inside, life. But plants need more than soil and water. They need light. They need nutrients. They need carbon dioxide. They need suitable temperatures. They need a stable environment. And every one of those conditions would need to be created. Sunlight could be used whenever possible. Mars still receives plenty of sunlight to support solar-powered systems and potentially provide light for agriculture. But natural sunlight would not always be reliable enough. Dust storms could reduce the available light. The seasons would change. The position of the sun would change. And a permanent agricultural system cannot simply stop growing because conditions outside have become inconvenient. Artificial lighting could therefore become important. LED systems could provide plants with controlled amounts of light. Different wavelengths could be adjusted. Light cycles could be carefully timed. The growing environment could be optimized. And then there is water. Every plant needs it. But water on Mars would be precious. So agricultural systems would need to use it efficiently. Hydroponics can circulate water through plant roots rather than allowing large amounts to disappear into soil. Other systems can recover moisture from the air. Condensation can be collected. Water can be filtered and returned to the growing system. The principle would be the same as everywhere else in the settlement. Waste as little as possible. Recover what can be recovered. Use resources more than once. The plants themselves could become part of that cycle. They absorb carbon dioxide. They release oxygen. They produce food. They create organic material. And when plant material is no longer useful, some of it could potentially be processed into other resources. Human waste could also become part of the agricultural cycle, but only after careful treatment. A permanent settlement would need to think about nutrients as carefully as it thinks about water. Nitrogen, phosphorus, potassium, and many other elements are essential for plant growth. On Earth, natural ecosystems move these materials continuously. On Mars, humans would need to help create those cycles. Imagine a settlement slowly becoming more circular. Food is grown. People eat. Organic waste is processed. Nutrients are recovered. Plants use those nutrients again. Water is collected, filtered, reused. Air moves between living spaces and growing areas. Carbon dioxide, produced by humans, becomes useful to plants. Oxygen produced by plants becomes useful to humans. It would not be a perfect closed ecosystem. Nothing created by humans is perfectly efficient. There would still be losses. There would still be waste. There would still be supplies arriving from Earth. But every successful cycle would reduce dependence. And, eventually, the settlement might grow more ambitious. A few plants become dozens. Dozens become hundreds. A small greenhouse becomes several. Food production expands. Perhaps crops that provide calories become especially important. Potatoes, grains, legumes, vegetables, fruit, Each would have different requirements. The settlers would have to decide what to grow. Space would be limited. Energy would be limited. Water would be limited. So agriculture would not simply be about growing whatever people enjoy eating. It would also be about efficiency. How many calories can be produced? How much water does the crop require? How much light? How much space? How long does it take to mature? How easy is it to cultivate? Some crops could be valuable for another reason, not because they provide many calories, but because they provide psychological comfort. Imagine someone who has lived on Mars for years. They walk into a greenhouse and see something that reminds them of Earth. A familiar leaf, a familiar flower, a familiar smell. That small connection could matter enormously, because food is not only fuel. Food is memory. It is culture. It is family. It is celebration. It is something people associate with home. A Martian settlement might eventually develop its own food traditions. Recipes could change. Ingredients could become local. People could create dishes that were impossible to make during the first missions. Children born on Mars might grow up eating food that their parents once considered impossible to produce there. Perhaps one day, someone would prepare a meal containing vegetables grown only a few rooms away. They would sit down with friends. They would talk. They would laugh. And the fact that the food came from Mars might no longer feel extraordinary. It would simply be dinner. That is when a settlement begins to change. When extraordinary things become ordinary, they become part of civilization. The first greenhouse would be an experiment. The 10th greenhouse would be infrastructure. The first harvest would be a historic event. The 100th harvest would be Tuesday. But reaching that point would take time. The first plants might fail. Seeds might not germinate properly. Nutrient systems might malfunction. Water could become contaminated. Lighting could fail. A disease could spread through a crop. A greenhouse could lose pressure. And unlike on Earth, there would be no surrounding countryside to provide replacement food. Agriculture would therefore need redundancy too. Multiple growing areas, different crops, stored seeds, backup lighting, backup water systems, emergency food supplies, and enough knowledge to restart production if something went wrong. The settlers would need to learn from every failure. Which plants grow best under Martian conditions? Which crops tolerate the available light? How much water is actually required? How do roots behave in low gravity? How do plants respond to increased radiation? How do microorganisms behave inside a closed Martian ecosystem? Some of these questions can be studied on Earth. Others will require actual experiments in space. Because Mars has something that Earth laboratories cannot perfectly reproduce. Mars itself, its gravity, its radiation environment, its atmospheric pressure, its cycles of temperature, its unique combination of environmental stresses. And that brings us to one of the deepest questions. What happens when plants become part of a human settlement on another planet? Because, eventually, they would no longer simply be crops. They would become part of the habitat. Plants could help manage carbon dioxide. They could contribute oxygen. They could provide food. They could create humidity. They could offer psychological comfort. They could make artificial environments feel alive. A greenhouse could become more than a farm. It could become a garden. And perhaps, for someone who has spent years surrounded by metal walls, that garden could become one of the most important places in the settlement. Imagine entering it at the end of a long day. Outside, the landscape is red. The sky is dim. Dust moves across the surface. Inside, there is green. Water is moving quietly. Leaves are growing. The air is warm. There is life everywhere. You stop for a moment. You look at a plant, something growing from a seed that traveled millions of kilometers, inside a world where no forest has existed for perhaps billions of years. And you realize this is not simply agriculture. It is the beginning of an ecosystem. Perhaps the first plants on Mars would be fragile, dependent on machines, dependent on humans, dependent on Earth. But generation by generation, the system could become more sophisticated, more efficient, more independent, and eventually, the first child born on Mars might walk into a greenhouse, pick something that was grown there, and eat it. For that child, there would be nothing miraculous about it. Mars would simply be the place where food grows. The red planet would have become, at least in one small way, a living world. But while plants might adapt to controlled Martian environments, the human body itself would face a much greater challenge. Plants can be grown under carefully designed conditions. Human beings carry their environment inside themselves. Our bones, our muscles, our hearts, our blood, our brains, all evolved on Earth. And Mars would ask them to function under conditions they have never experienced for generations. So eventually, the question becomes much more personal. Could the human body actually adapt to a life on Mars? Mars can provide shelter. It can provide water. It can provide energy. Perhaps one day, it can even provide food. But there is something much harder to replace: the human body. We can build machines to produce oxygen. We can build systems to recycle water. We can build greenhouses to grow plants. But we cannot simply build a new human body, one designed for Mars. Our bodies were shaped by millions of years of life on Earth. And Earth has one condition that Mars cannot provide: gravity. On Earth, gravity is always present. We rarely notice it because it has been part of every moment of our lives. From the moment we are born, our bodies are responding to it. Our muscles work against it. Our bones support us against it. Our hearts pump blood through it. Our balance systems are constantly interpreting it. Gravity is not simply something outside the human body. It is part of the environment our bodies were built around. On Mars, gravity is only about 38% as strong as Earth's. That sounds like a simple change. You would weigh less. You could jump higher. Moving heavy objects could become easier. But inside the human body, the consequences could be much more complicated. Our bones are living tissue. They constantly remodel themselves. When bones experience mechanical stress, the body responds by maintaining their strength. When that stress decreases, bone density can decrease as well. We have already seen this happen in astronauts living in microgravity. Without the normal mechanical loading provided by Earth's gravity, bones can lose mineral density. Muscles can weaken. The cardiovascular system changes. Balance becomes more difficult when returning to Earth. Mars is not microgravity. That distinction matters. A person standing on Mars would still experience substantial gravity, but it is significantly less than what the human body evolved under, and we do not yet know exactly what long-term exposure to Martian gravity would mean. A few months is one thing. A few years is another. A lifetime is something completely different, and a generation is another question entirely. Imagine waking up on Mars after living there for several years. You stretch, you stand, your body feels lighter. You walk through the habitat. Perhaps at first, the difference feels almost pleasant. Then you remember that your muscles and bones are living in an environment where gravity is pulling on them much less strongly. Exercise would become part of daily life, not simply for fitness, but for survival. Resistance training could help maintain muscle and bone strength. Exercise systems might become some of the most important equipment inside the settlement. Imagine a small room filled with exercise machines. People would use them every day, pulling against resistance, lifting, pushing, running, working their muscles against artificial loads. The routine might become as ordinary as brushing your teeth, but exercise cannot answer every question. We do not yet know whether the human body can remain healthy indefinitely under Martian gravity. We have no long-term human population living at 0.38 grams. There is no historical example to study. No civilization on Mars has existed for thousands of years, so there is a fundamental uncertainty. What happens to a child who grows up there? That question is much more difficult. A child is not simply an adult in a smaller body. The skeleton is developing. The nervous system is developing. The cardiovascular system is developing. The balance system is developing. Every part of the body is interacting with its environment, and gravity is part of that environment. On Earth, children grow up learning how to stand, how to walk, how to run, how to jump. Their brains learn how the body moves through a one-gravity environment. A child born on Mars would experience something different from the very beginning. Would their bones develop normally? Would their muscles become strong enough for life on Earth? Would their cardiovascular system develop differently? Would their balance system adapt to lower gravity? Could a person born on Mars ever safely return to Earth? We do not know. And perhaps the most important question is even simpler. Would a human being born on Mars still be physically capable of living on Earth? It is possible that long-term development in low gravity could create challenges we have not yet fully understood. That uncertainty alone would make human reproduction on Mars an enormous scientific and ethical question. And then there is the heart. The cardiovascular system is designed around Earth's gravity. Every time your heart beats, it pushes blood through a body that is being pulled downward by gravity. Your blood vessels and heart work together to maintain circulation. Change the gravitational environment, and the system changes. In lower gravity, the body does not have to fight gravity in exactly the same way. Fluid distribution changes. The cardiovascular system adapts. Over long periods, those adaptations could have consequences. And then there is radiation. This may be one of the greatest differences between life on Earth and life on Mars. Earth's atmosphere provides substantial protection from high-energy particles arriving from space. Mars provides much less. Its atmosphere is too thin to offer the same level of shielding. A Martian settlement could therefore expose its inhabitants to more radiation than people living on Earth. The risk would accumulate over time. A short mission might be manageable. A lifetime is a much larger problem. This is another reason underground habitats could become important. The Martian ground could serve as a natural shield. The more material placed between people and the outside environment, the more protection they can receive from certain forms of radiation. Imagine spending most of your life underground. You might work underground, sleep underground, grow food underground, exercise underground, meet friends underground. Perhaps only occasionally, you would put on a spacesuit and climb toward the surface. For someone born there, that might not seem strange. It would simply be life. The surface would become a place people visit. The underground settlement would become home. But there is another problem. Humans need sunlight. Not simply because it makes us feel good, but because light helps regulate biological rhythms. Our bodies have internal clocks. They respond to cycles of light and darkness. A Martian settlement would therefore need to think carefully about artificial lighting. Mars has a day that is surprisingly similar in length to Earth's. A Martian solar day, called a sol, is only about 40 minutes longer than an Earth day. That would make daily schedules easier to adapt to than on many other worlds. But the similarity ends there. The light itself would be different. The atmosphere would filter sunlight differently. Dust could alter the sky. Sunsets would have their own appearance. And inside the habitat, artificial lighting could become essential for maintaining healthy routines. The settlement might simulate sunrise, brighten gradually, maintain daylight, then slowly reduce the light toward evening. At night, the habitat could become quiet and dim. The goal would be to give human beings a rhythm that feels natural, even while living inside a machine. Sleep would matter. A population under constant environmental stress would need adequate rest, and psychological health would be just as important as physical health, because the body would not be the only thing adapting to Mars. The mind would have to adapt too. Imagine living in the same enclosed environment for months. The same corridors, the same walls, the same people, the same routines. Outside, a landscape extending beyond the horizon. But you cannot simply walk away. You cannot take a weekend trip to another city. You cannot fly home. The psychological challenge could be enormous. A small community would need ways to create privacy, personal space, recreation, connection, meaning. People would need more than survival. They would need reasons to look forward to tomorrow. That might come through work, through relationships, through exploration, through art, through education, through gardens, through simple routines. And perhaps this is where the human body and human mind become inseparable. A person who is physically healthy but psychologically overwhelmed is not truly thriving. A settlement that measures oxygen and temperature perfectly but ignores loneliness would still be fragile. Medicine would therefore become extremely important. A Martian settlement could not depend entirely on Earth for every medical emergency. Doctors and medical technology would need to be available locally. The settlement would need to handle injuries, infections, dental problems, broken bones, pregnancy, chronic illnesses, emergency surgery, and eventually, perhaps conditions we have never encountered in a permanent Martian population. The distance from Earth would make medical care different. On Earth, if a hospital does not have a particular piece of equipment, another hospital may be only an hour away. On Mars, there is no neighboring planet to call for an ambulance. The community would need to be prepared. Medical knowledge would have to be broad. Equipment would need to be reliable. And perhaps artificial intelligence could eventually assist doctors by helping diagnose conditions or guide procedures. But technology would still depend on people who know how to use it. The human body would therefore become one of the greatest limits on permanent settlement. We can build habitats. We can manufacture oxygen. We can grow food. We can generate energy. But we still do not know whether human beings can safely live on Mars for their entire lives. That uncertainty would become even more important when the first children are born. Because the moment a child is born on Mars, the settlement is no longer simply an expedition. It has become a society with people who did not choose to travel there. People whose entire experience of the universe began beneath a Martian sky. Their first steps would happen under lower gravity. Their first memories would form inside artificial habitats. Their first view of nature might be a red desert. Their first night sky would not be the same sky their ancestors knew. And perhaps Earth would be a story. Their parents might show them pictures: blue oceans, green forests, clouds, mountains, cities, rain, snow. They might explain that on Earth, you can open a door without wearing a pressure suit. You can walk beside a river. You can breathe anywhere. You can stand beneath a sky filled with clouds. To a child born on Mars, that might sound almost impossible. The Earth could become something like a distant ancestral homeland, beautiful, important, but foreign. And this raises a question far larger than biology. If humans eventually live on Mars for generations, will they still think of themselves as Earth humans, or will a new identity emerge? Perhaps they would still call themselves human. Perhaps they would call themselves Martian. Perhaps both. Perhaps the distinction would become less important with time. But before any of those cultural questions can be answered, one basic scientific question remains. Can the human body truly tolerate Mars? We know some things. We know what low gravity does during spaceflight. We know that radiation is a serious concern. We know that exercise can reduce some of the physical effects of reduced gravity. We know that artificial environments can keep people alive. But we do not yet know the complete story. And that uncertainty is important. Because Mars is not a laboratory where every experiment can be repeated safely. A permanent human settlement would be an experiment involving real lives. Every generation would teach us something new. Every child born there would reveal something about human development. Every decade would reveal something about long-term adaptation. Perhaps the human body would adapt better than we expect. Perhaps technology would compensate for many of the problems. Perhaps artificial gravity could eventually become possible inside rotating habitats. Or perhaps some limitations would prove much harder to overcome. We simply do not know yet. And that may be one of the most fascinating parts of the entire idea. Mars does not only challenge our engineering, it challenges our biology. It asks whether the human body, a body shaped by Earth, can become the body of a species that lives somewhere else. But even if we solved every physical problem, even if we could keep people healthy, even if every habitat worked perfectly, there would still be another challenge waiting. One that cannot be solved with oxygen generators, exercise machines, or radiation shielding: distance. Because eventually, every person living on Mars would have to confront the same quiet truth. Earth is far away, and sometimes farther than the mind is prepared to imagine. There is one part of living on Mars that no machine can completely solve: distance. You can build a habitat. You can produce oxygen. You can grow food. You can generate electricity. You can protect yourself from radiation. But none of those things make Earth closer. And eventually, every person living on Mars would have to learn what it means to be very far from home. Imagine waking up one morning and reaching for a communication screen. There is a message waiting for you. Someone on Earth sent it during the night. Perhaps it is from a family member, perhaps a friend, perhaps someone you have not spoken to in weeks. You open the message, and for a moment, the distance between two worlds feels smaller. You can hear a familiar voice, see a familiar face, remember another life. Then the message ends, and Mars is still there. The distance between Earth and Mars is constantly changing. The two planets travel around the Sun at different speeds. Sometimes they are relatively close together. Sometimes they are separated by hundreds of millions of kilometers. That distance creates a problem that cannot be solved by simply building a more powerful telephone. Information itself has a speed limit. The fastest possible message travels at the speed of light. So when someone on Mars sends a message to Earth, the message takes time to arrive. And when someone on Earth answers, that answer also takes time to return. The exact delay depends on where the planets are in their orbits. Sometimes it can be only a few minutes in one direction. At other times, it can be more than 20 minutes. That may not sound like much until you try to have a conversation. You speak, then you wait. The person on Earth hears you. They answer. Then you wait again. There is no natural rhythm, no immediate response, no possibility of interrupting someone halfway through a sentence. No simple, "Are you still there?" A conversation that feels effortless on Earth would become a carefully timed exchange between worlds. You would need patience. You would need to finish your thought. You would need to wait, and eventually, you might become accustomed to it. But there is another complication. Sometimes, Mars and Earth are positioned in such a way that communication becomes even more difficult. For periods of time, the Sun can come between the two planets from our perspective. During these periods, direct communication can be disrupted or severely limited. A Martian settlement would need to expect these communication gaps. Imagine knowing that for several days, perhaps longer, communication with Earth may become unreliable. There is no quick call, no immediate conversation, no instant reassurance. The settlement would have to continue operating on its own. For a scientific expedition, that is a technical challenge. For a permanent community, it becomes part of daily life. People would grow up knowing that sometimes Earth would simply be unavailable. That would change the emotional meaning of distance. On Earth, if someone you love lives on the other side of the planet, you know you can reach them. A phone call is almost immediate. A message can arrive in seconds. An airplane can cross the distance in hours. On Mars, none of that is guaranteed. If something happens to someone on Earth, you cannot simply get on a plane. If someone on Mars becomes seriously ill, Earth cannot send an ambulance. If a family member dies, there may be no possibility of being there. The emotional consequences could be profound. Mars would not only be far away physically, it would be far away emotionally. And then there is the view. Imagine standing outside the habitat. The suit is protecting you. The communication system is working. The settlement is behind you. You look upward, and somewhere in that sky, Earth is visible. It would appear tiny, a point of light, a distant world. Perhaps you would know exactly where it is. Perhaps you could even identify it without instruments. But you would not see continents. You would not see cities. You would not see oceans. You would only see a small, distant point, carrying the entire history of your species. Every human being who ever lived was born there. Every ancient civilization, every language, every war, every song, every scientific discovery, every friendship, every family, every first step, every goodbye, all of it happened on that small world. And now, you are standing somewhere else. Perhaps that would be one of the strangest experiences of being a Martian settler. Looking at Earth and realizing that home has become a planet in the sky. At first, that feeling might be overwhelming. The first explorers might spend hours looking toward Earth. They might take photographs. They might talk about it constantly. They might count the days until the next communication window. But humans are adaptable. Eventually, Mars would become familiar. The red landscape would become normal. The habitat would become normal. The lower gravity would become normal. The communication delays would become normal. And Earth might slowly become something different. Not less important, just more distant. A place of origin, a place remembered, a place loved, but no longer the center of every decision. This could become especially difficult for people who leave Earth as adults. They would remember oceans, rain, trees, open landscapes, birds, cities, the smell of soil after rainfall. The feeling of standing outside without a helmet. For someone born on Mars, those memories would not exist. Their experience of nature would be different. They might know Earth through photographs, videos, stories, virtual reality, family memories, but they would not have experienced it themselves. And that difference could shape an entire culture. Imagine two people talking. One says, "I remember rain." The other asks, "What does it feel like?" The first person tries to explain. Water falling from the sky, clouds covering the sun, the smell of wet ground, the sound against windows, the feeling of standing outside without protection. To someone born on Mars, it might sound almost like a story from another world, because it would be. That is where loneliness becomes more complicated. Loneliness is not simply being alone. You can be surrounded by people and still feel isolated. And on Mars, the community would likely be very small. The first permanent settlements might contain only a handful of people, perhaps dozens. Even later, the population could remain tiny compared with Earth. That means relationships would become extremely important. You would see the same people every day, work with them, eat with them, live near them, possibly depend on them for survival. There would be very little room for disappearing. On Earth, if you have an argument with someone, you can leave. Go for a walk. Drive somewhere. Visit another friend. Spend the evening somewhere else. On Mars, the options would be limited. You could walk through another part of the habitat, but everyone would still be nearby. The same corridors, the same rooms, the same community, the same planet outside. That could create enormous social pressure. A settlement would need to think carefully about personality, compatibility, conflict resolution, privacy, leadership, mental health. The people chosen for early missions would need technical skills, but technical ability alone would not be enough. They would need to cooperate, communicate, handle disagreement, support each other, and remain psychologically stable under isolation. Imagine a community of 10 people. One person is a doctor, another is an engineer, another specializes in agriculture, another manages energy systems, another studies geology. Each person has an important role, but they are also human beings. They will disagree. They will become tired. They will become frustrated. They will miss people. They will have bad days. A successful settlement would therefore need to treat psychological health as part of life support, not as an optional luxury, but as something essential. There might be private rooms, recreation spaces, exercise areas, gardens, entertainment, communication systems, virtual environments, scheduled social activities, perhaps even simulated landscapes from Earth. Imagine putting on a headset and suddenly standing beside an ocean. You can hear waves, feel sunlight, see a blue sky. For a few minutes, you are not on Mars. Then you remove the headset. The room is still there. The walls are still there. The red planet is still outside. But perhaps, for those few minutes, your mind was allowed to travel somewhere your body could not. That might become an important part of Martian life. Because humans have always used imagination to overcome distance. Stories, music, art, letters, photographs. Now technology could make that connection even more vivid. But nothing would completely replace physical presence. A message from someone you love is not the same as sitting beside them. A video call is not the same as a hug. A photograph of Earth is not the same as standing beneath an open sky. That is why the first settlers might experience a strange mixture of emotions. They could be proud. They could be excited. They could feel that they are part of something historic. And at the same time, they could feel deeply homesick. Perhaps the hardest moments would not be emergencies. They might be ordinary moments. A birthday, a holiday, a family celebration happening on Earth, a child being born, a loved one getting married, a familiar place changing without you. Imagine receiving a message from Earth and realizing that someone you love has grown older while you were away. You can see their face on a screen, but you cannot reach through it. You are separated by an entire planet. And then you look outside. Mars is quiet. The horizon is enormous. The sky is dark. The habitat lights reflect against the window. That moment might make the scale of the journey feel very real. Because humanity could build machines capable of crossing space, but the emotional distance between worlds would remain. Still, there could also be another side to the experience. The knowledge that you are part of something larger than yourself. The first generation living on another planet would carry an extraordinary responsibility. They would be creating a place where nobody had ever lived before. Every ordinary action would have meaning. Growing food, repairing equipment, teaching a child, building a new room, collecting water, walking across the surface, watching a sunrise. The settlement would slowly become a collection of memories. The first room, the first greenhouse, the first school, the first hospital, the first garden, the first child born there, the first person to spend an entire lifetime on Mars. And perhaps one day, the loneliness would become less severe, not because Earth became closer, but because Mars became fuller. More people, more communities, more settlements, more places to go, more lives being created. A child born on Mars would not necessarily feel stranded. Mars would be their world. Their friends would be there. Their family would be there. Their school would be there. Their memories would be there. Their future would be there. And that changes everything. The first settlers would think of Mars as somewhere they had gone. Their children might think of Mars as somewhere they belonged. Their grandchildren might never use the word colony. They might simply say home. But for that to happen, the settlement would need to grow. It would need more than scientists, more than engineers, more than temporary visitors. It would need a functioning community, people capable of producing what they need, people capable of repairing what breaks, people capable of building what comes next. At some point, the question would no longer be, can we survive on Mars? It would become, Can we build a civilization here? And that is a much larger question, because survival can be measured in days. A settlement can survive for years, but civilization must survive across generations. A small settlement can survive with very little, a handful of people, a few habitats, carefully rationed supplies, regular communication with Earth, and enough machinery to keep the basic systems running. But survival is not the same as independence, and independence is not the same as civilization. Imagine the settlement several decades after the first landing. The original habitat is no longer alone. New structures have appeared nearby. A greenhouse stands where there was once only dust. A workshop has been built beside the main habitat. Storage facilities are connected by protected corridors. There are places for research, places for medical care, places where people gather, and somewhere, children are growing up. The settlement is beginning to look less like a research station and more like a community. But beneath everything, there is still one question. Can Mars provide enough of what this community needs? Because eventually, the shipments from Earth need to become less important, not necessarily disappear completely, but become less essential. One of the first major steps would be producing fuel locally. Every spacecraft arriving from Earth needs enormous amounts of energy to travel between worlds. If vehicles must also carry all the fuel needed for the return journey, the amount of material that must be launched becomes enormous. But if some of that fuel can be produced on Mars, the equation changes. Water could become especially valuable. Hydrogen and oxygen can be obtained from water. Those elements can be used in propulsion systems. The Martian atmosphere also contains carbon dioxide, which can provide carbon and oxygen for certain chemical processes. With enough energy and appropriate equipment, local resources could potentially be transformed into useful propellants. Imagine a spacecraft arriving from Earth. It lands. Its crew enters the settlement. But instead of waiting for another spacecraft from Earth to bring all the fuel needed for the return trip, the settlement begins producing it locally. Tanks slowly fill. Machines operate continuously. The raw materials come from Mars. The energy comes from systems built on Mars. That would represent something important. Mars would no longer simply be a destination. It would be participating in the transportation system itself. But fuel is only one part of independence. Machines break, tools wear out, seals deteriorate, electronics fail. A settlement cannot continuously wait months or years for every replacement part to arrive from Earth. So, eventually, manufacturing would become essential. At first, perhaps only simple objects: tools, brackets, containers, pipes, mechanical components. Then, more complicated parts. Three-dimensional printing could become useful. Local materials could be processed into feedstock. Metals could be extracted and refined. Ceramics could be produced. Glass could potentially be manufactured. Plastics could be recycled. And gradually, the settlement could begin making more of what it needs. This would be a slow process. Mars does not provide an industrial civilization ready to use. There are no mines filled with processed metal, no factories, no roads, no electrical grid, no supply chain. Everything would have to be built, and that is where the scale of the challenge becomes clearer. On Earth, a single object may depend on thousands of other objects. A factory depends on electricity. Electricity depends on power stations. Power stations depend on materials. Materials depend on mines. Mines depend on machines. Machines depend on factories. Factories depend on engineers. And all of these systems depend on transportation. A mature civilization is therefore not one machine. It is a network of systems supporting other systems. Mars would need to build that network, almost from nothing. The first workshops might therefore be extremely important, not because they would look impressive, but because they would give the settlement something Earth currently provides automatically: the ability to make replacements. Imagine a critical machine breaks. The old solution would be simple: send a replacement from Earth. But the next shipment might not arrive for months. Instead, the engineers examine the broken component. They design a replacement. They manufacture it locally. They install it. The machine begins working again. That moment would be quiet. No dramatic announcement. No giant celebration. But it would represent a major step. The settlement has solved a problem using Mars itself. Construction would develop in the same way. At first, habitats would probably be brought from Earth, but transporting large amounts of building material across interplanetary space is expensive. Eventually, using local materials would become increasingly attractive. Martian regolith could potentially be processed into construction materials. It might be used to create bricks, concrete-like materials, protective structures, road surfaces, radiation shielding, or other forms of infrastructure. The settlement could slowly begin to build itself, not entirely, not immediately, but increasingly. A new room would not necessarily need to arrive from Earth. Perhaps only the machinery would. The material could come from the ground beneath the settlers' feet. That changes the psychology of a place. A habitat shipped from Earth always feels like something borrowed. A building constructed from Martian material begins to feel like something belonging to Mars. And then there is medicine. A civilization cannot exist without people who can care for one another. Early settlements would need doctors, nurses, medical equipment, pharmaceutical supplies, emergency procedures, and systems capable of dealing with injuries far from Earth. Imagine a serious accident. Someone is injured during construction. The settlement cannot call an ambulance from another city. There is no hospital nearby. The medical team must respond immediately. That means medical knowledge would have to become part of the infrastructure. The settlement might eventually need operating rooms, diagnostic equipment, pharmacies, laboratories, dental care, mental health services, and perhaps systems capable of producing certain medicines locally. The more independent the settlement becomes, the more diverse its skills must become. One person cannot know everything. A community needs engineers, farmers, doctors, teachers, scientists, technicians, builders, mechanics, computer specialists, and many other professions. This creates an interesting problem. The first settlement may be chosen for efficiency. Everyone has a specific role. Everyone is highly trained. Everyone is necessary. But a civilization cannot remain a small team forever. Eventually, people need families. Children need teachers. Communities need artists, musicians, writers, historians, people whose work is not directly related to keeping the oxygen system running. That is one of the signs that a settlement is becoming something larger. Life begins to expand beyond survival. Imagine a Martian school. Children sit inside a classroom. Perhaps outside the window, there is nothing but red rock. The teacher is explaining the history of Earth. The students know the names of oceans they have never seen. They know that their ancestors came from a blue planet, but they have never lived there. Their education would include science and engineering, but also history, language, art, philosophy, music, culture. Because a civilization is not simply an efficient machine for keeping people alive. It is a way of life. And eventually, the community would need more food. A single greenhouse would not be enough. Agriculture would expand. More growing rooms, more crops, more storage, more water systems, more biological research. Perhaps some parts of the settlement would become agricultural districts, rows of plants under artificial lights, controlled environments, automated systems, workers moving between growing areas, water and nutrients circulating continuously. The settlement would begin to develop specialized infrastructure, energy districts, agricultural areas, manufacturing zones, research facilities, residential areas, medical centers, transportation corridors. At some point, the settlement might no longer fit inside a single habitat. It becomes a network. Several communities connected together, perhaps separated by kilometers, but linked through protected transportation systems. And then something subtle happens. The community begins making decisions for itself. The delay between Mars and Earth makes direct control difficult. Earth can send instructions, but those instructions may arrive after the situation has already changed. So, the Martian settlement would need local authority, local leaders, local laws, local emergency procedures, local decisions. At first, that independence might be purely practical. Later, it could become political. The people living on Mars might begin asking questions. Why should decisions about our lives be made by people who live millions of kilometers away? Why should our laws be written on another planet? Why should our future depend on governments we cannot immediately reach? These questions would not necessarily lead to conflict, but they would almost certainly lead to discussion, because distance changes politics. Imagine a decision that requires an immediate response. A piece of infrastructure has failed. The settlement must choose how to allocate limited resources. There is no time for a long conversation with Earth. The Martian community must decide. The more often this happens, the more capable the settlement becomes of governing itself. And gradually, a colony becomes something different. Perhaps the people living there still call themselves citizens of Earth. Perhaps they develop a separate identity. Perhaps they eventually consider themselves both. But the important change is not the name. It is the ability to continue without constant rescue. That is the difference between a base and a civilization. A base exists because someone built it. A civilization exists because people can continue building. The first Martian settlement might depend on Earth for almost everything. The next generation might depend on Earth for some things. The generation after that might depend on Earth mainly for specialized technologies. And perhaps, many generations later, Mars could produce almost everything necessary for everyday life. Not everything. The relationship between Earth and Mars might never completely disappear. There would always be knowledge to exchange. Scientific discoveries, cultural connections, trade, people traveling between worlds. But the difference would be enormous. If Earth disappeared tomorrow, a truly independent Martian civilization might continue. That is the point at which humanity would have achieved something unprecedented. For the first time, our species would no longer exist in only one place. A catastrophe affecting Earth would no longer necessarily mean the end of humanity, and a catastrophe affecting Mars would not necessarily mean the end of everyone. The risk of extinction would begin to spread across space. Instead of one fragile home, there would be several. But even that raises another question. What does it mean to remain on Mars forever? A base can survive for years. A city can survive for centuries. But a civilization needs generations. It needs children who are born there, grow up there, and eventually raise children of their own. And that would force humanity to confront something much deeper. Would Mars remain a place humans visit? Or could it become a place where humans truly belong? A mission can last for years. A research station can survive for decades. A city can survive for centuries. But a civilization is something different. A civilization must survive generations. And that means something very important would have to happen on Mars. Children would have to be born there. They would grow up there. They would become adults there. And eventually, they would raise children of their own. Imagine a child waking up on Mars. There is no memory of Earth. No childhood spent beside an ocean. No walk through a forest. No experience of rain falling from an open sky. Mars is simply home. The red landscape outside the window is not strange. The habitat is not strange. The lower gravity is not strange. The distant Earth is not strange. It is simply another world. Far away. That child might learn about Earth in school. They might see photographs of blue oceans, green forests, white clouds, mountains, cities filled with millions of people. They might learn that every human being who lived before their ancestors arrived on Mars came from that planet. But for them, Earth would be history. This would create a profound change. The first settlers would look toward Mars and think about Earth. Their children might look toward Earth and think about their ancestors. Their grandchildren might simply look around and see Mars. Over generations, the emotional center of human life could slowly move. Not because people stopped caring about Earth, but because life became rooted somewhere else. A Martian child would have memories that belonged only to Mars. Their first steps might happen in lower gravity. Their first school might be inside a habitat. Their first view of the landscape might be a red horizon. Their first friendships would happen there. Their first dreams would be formed there. Their first sense of belonging would be connected to Mars. And eventually, someone might ask them a simple question. Where are you from? And they might answer, Mars. That single answer would represent an enormous change in human history. Because for almost all of our existence, there has only been one place we could call home, Earth. But permanence creates difficult responsibilities. If people are going to live on Mars for generations, the settlement cannot depend completely on Earth. It would need to reproduce its own knowledge, its own skills, its own infrastructure, its own culture. Imagine an engineer teaching a young apprentice how to repair a critical machine. The apprentice learns, then teaches someone else. That person teaches the next generation. Knowledge begins to move through time rather than across space. This would become essential because a civilization separated from Earth cannot simply assume that the knowledge of its ancestors will always be available. It must be preserved. Libraries would matter. Archives would matter. Schools would matter. But living knowledge would matter even more. People would need to know how systems work, not simply where the instructions are stored. A Martian civilization might therefore place enormous value on education. Every generation would inherit a world that required maintenance. Every generation would need to understand how to keep it alive. And perhaps, over time, Mars would develop its own traditions. A holiday might commemorate the first landing. Another might remember the first child born on Mars. There could be anniversaries connected to the first greenhouse, the first independent manufacturing facility, the first community built without direct Earth support. Songs might be written about the red horizon. Stories might be told about the early settlers. Children might grow up hearing about the people who first crossed the space between worlds. Culture would begin to form, not because someone designed it, but because humans naturally create meaning around their experiences. And eventually, the question of identity would become unavoidable. What would it mean to be human on Mars? Would people still consider themselves Earthlings? Would they call themselves Martians? Would they use both? At first, the answer would probably be simple. They would still be human. But after many generations, the differences could become more complicated. Language could change. Words could develop new meanings. Some expressions from Earth might disappear. New words could emerge to describe Martian environments. New traditions could form around life under the red sky. Even architecture might change. A building designed for people born on Mars could be different from one designed for visitors from Earth. The spaces might reflect local gravity, local climate, local culture, local needs. And then there is the possibility of biological adaptation. This is where the future becomes much more uncertain. Humans living on Mars for many generations could potentially experience different selective pressures from people living on Earth. But natural evolution is slow, very slow. For meaningful biological differences to accumulate naturally, many generations would be required, and modern technology could change the process completely. Humanity might eventually begin modifying itself, perhaps to tolerate radiation better, perhaps to adapt to lower gravity, perhaps to improve certain aspects of health, or perhaps simply because the technology becomes available. These ideas remain speculative. We do not know what future humans would choose, but the possibility raises a fascinating question. If humans change enough, at what point would we stop calling them the same species? Maybe the people of Mars would still be recognizably human. Maybe they would be somewhat different. Maybe technology would become so deeply integrated with biology that the distinction between human and machine would become harder to define. But perhaps none of that would be necessary. Mars does not necessarily need to become biologically comfortable. It only needs to become manageable. This is where the idea of terraforming appears. The dream is enormous. Instead of building small, protected islands of life, we could attempt to change the planet itself, make the atmosphere thicker, raise temperatures, release gases, create a more Earth-like environment. Eventually, perhaps allow liquid water to remain stable on the surface. It is an extraordinary idea, a planet transformed by its inhabitants. A world that once seemed completely hostile, slowly becoming more familiar. But Mars is not an empty version of Earth, waiting to be repaired. Its atmosphere is extremely thin. Its climate is cold. Its magnetic environment is very different. It receives less sunlight than Earth. Its surface has lost much of the atmospheric protection that Earth possesses, and the amount of material required to dramatically transform the planet would be enormous. Terraforming would not be a project for one generation, or even a few generations. It could require timescales far beyond ordinary human planning. Perhaps centuries, perhaps much longer. And some proposed methods may simply be impractical with known technology. There is also another question. Should we even try? Mars has its own geological history, its own landscapes, its own chemistry, its own scientific value. Transforming the planet on a massive scale could destroy information about its natural state. Perhaps humanity would eventually decide that Mars does not need to become another Earth. Perhaps the better approach would be different. Instead of transforming the entire planet, we could transform small parts of it. A habitat could become a forest. A greenhouse could become a garden. A network of underground cities could create artificial ecosystems. A settlement could become comfortable without changing the entire planet. In that sense, Mars might remain Mars, and humans would simply learn how to live there. There is something almost poetic about that idea. We do not need every world to become Earth. We only need to learn how to belong to more than one kind of world. Earth taught humanity how to live beneath an atmosphere. Mars might teach humanity how to live inside one. The difference may sound small, but it would represent an enormous change. For most of our history, we lived directly inside nature. Our homes protected us from some aspects of the environment, but the environment remained outside. On Mars, the boundary would become much clearer. The habitat would be an island. Outside, the planet. Inside, life. Air would have to be manufactured. Water would have to be recycled. Temperature would have to be controlled. Radiation would have to be managed. Food would have to be grown. Waste would have to be processed. Every part of life would depend on systems. And that means the meaning of home would change. On Earth, home is a place. On Mars, home might be a life support system. That may sound cold, but humans have always adapted their idea of home. A cave was once home. A village became home. A ship became home. A spacecraft can become home. Perhaps one day, a Martian habitat will feel just as natural to its inhabitants. And perhaps that is the real test. Not whether Mars looks like Earth, not whether the atmosphere becomes breathable, not whether oceans cover the surface, but whether a person can wake up there, look outside, and feel that they belong. If that happens, then Mars would no longer simply be a place where humans survive. It would be a place where humans live. And that distinction matters, because surviving somewhere for a year is an engineering problem. Living somewhere for a lifetime is a biological problem. Building a community is a social problem. And remaining there for centuries is a civilization problem. Mars would have to pass all 4 tests, and perhaps one day it could. But even if humanity succeeds, there would still be something strangely beautiful about the idea. A planet that was never designed for us, quietly becoming a place where people wake up in the morning. A place where children learn, where people grow food, where friends meet, where stories are told, where someone might look through a window at sunset and feel completely at home. And perhaps that is enough. Maybe Mars does not need to become another Earth. Maybe humanity does not need to recreate the world it came from. Maybe the real achievement would simply be learning how to build a small island of life inside a world that was never meant to hold us. And after all the engineering, all the science, all the uncertainty, perhaps the most important question would become very simple. What would it feel like to spend a quiet night there? The work is finally finished. The machines continue running quietly. The greenhouse lights glow softly behind thick walls. Water moves through hidden pipes. Air is being filtered and recycled. Energy is being stored for the night. And outside, Mars is becoming dark. The sun is disappearing behind the distant mountains. Its light stretches across the landscape, turning the red ground into shades of orange, then brown, then almost black. The shadows grow longer. The temperature begins to fall, and slowly, the world outside becomes silent. Inside the habitat, there is still life. Someone is preparing dinner. Someone else is checking the systems. A scientist is reviewing the day's measurements. A child is finishing a lesson. Another person is looking through a window. They pause, and simply watch. There is no ocean outside, no forest, no rain, no birds moving through the air, no clouds drifting across a blue sky. Only a vast landscape stretching toward the horizon. The habitat is small, almost fragile, a tiny structure surrounded by an enormous world. And yet, inside those walls, everything necessary for life is happening. People are breathing, plants are growing, water is circulating, food is being prepared, conversations are taking place. Someone is laughing, someone is thinking, someone is remembering Earth. Someone is already dreaming about tomorrow. It is strange to imagine a planet that appears completely lifeless, containing a small pocket of human life. The machines do not look heroic. They simply work. Fans move air, pumps move water, computers monitor pressure, sensors watch temperature, batteries store energy, filters remove unwanted particles. Every system quietly performs its task. If one system fails, another may take over. If something breaks, someone repairs it. If a component becomes unreliable, a replacement is prepared. The settlement survives because thousands of small things continue working together. That is what makes the habitat more than a shelter. It is an artificial environment, a small world inside a world. Perhaps this is one of the most remarkable things humanity could ever build. Not the largest structure, not the most powerful machine, but a place where life can continue, even when the environment outside says that it should not. Outside, the pressure is almost non-existent compared with Earth. The air cannot be breathed. The cold is intense. Radiation reaches the surface. Dust covers the ground. The landscape offers little protection. And yet, behind a few walls, there is warmth. There is oxygen. There is water. There is food. There is light. There is life. Perhaps that contrast would become one of the defining experiences of living on Mars. You would constantly feel the difference between inside and outside. Inside, humanity. Outside, Mars. And perhaps at night, the distinction would become even stronger. The windows would reflect the warm lights of the habitat. Beyond them, the landscape would disappear into darkness. Someone might turn off the lights in one room and look outside. The stars would begin appearing, one by one. Mars has a thin atmosphere. There would be much less scattering of light than on Earth. The night sky could appear incredibly dark, and the stars would feel close. But among them, there would be something familiar. Earth. It would be only a distant point of light, sometimes bright enough to notice, sometimes difficult to distinguish without instruments. But it would be there. Imagine looking at it, knowing that somewhere on that tiny point, billions of people are living. Cities are glowing. Oceans are moving. Clouds are crossing the sky. Trees are growing. Children are falling asleep. People are walking through streets. Someone is probably looking at the sky and thinking about Mars. Two worlds looking toward one another, separated by millions of kilometers, connected by memory. Perhaps the person inside the Martian habitat would feel something unexpected. Not necessarily sadness, maybe gratitude, because Earth would suddenly appear different from this distance. More fragile, more beautiful, more precious. From Mars, Earth would no longer be an enormous world beneath your feet. It would be a small planet in the darkness. And perhaps that perspective would make something clear. Home does not have to be enormous to matter. Mars itself is enormous. But the habitat is tiny. A person could walk through it in minutes. And yet, that small space could contain an entire human life. A bedroom, a kitchen, a greenhouse, a classroom, a laboratory, a medical room, a place to exercise, a place to sit quietly. Perhaps someone would have a favorite window, a place where they watch the sunset. Perhaps another person prefers the greenhouse. Someone else enjoys the workshop. Someone might simply sit near the entrance, listening to the quiet sound of the ventilation system. Over time, the habitat would become familiar. The sounds would become familiar. The routines would become familiar. The landscape would become familiar. And that is how humans turn unfamiliar places into homes. Not by changing everything around them, but by filling the space with memories. A mark on a wall, a photograph, a chair, a book, a plant, a table where people eat together, a small object brought from Earth. The first settlers might carry personal objects with them, something almost meaningless to anyone else, but deeply important to them. A photograph, a letter, a piece of jewelry, a child's drawing, a small stone from Earth. That object might sit inside the habitat, millions of kilometers from the planet where it came from. And perhaps years later, someone else would look at it. A child born on Mars. They would ask, "What is this?" And someone would explain, "It came from Earth." That simple object could become a piece of history, a connection between worlds. But Mars would also create its own memories. The first sunrise, the first harvest, the first birthday, the first school lesson, the first song written there, the first house built from Martian materials, the first generation that never lived on Earth. Slowly, Mars would stop being only a destination. It would become a place filled with stories. And perhaps that is how a second home is created. Not through atmosphere, not through oceans, not through forests, but through memory. A world becomes home when someone has something to remember there. Outside, the night continues. The sun has completely disappeared. The mountains are silhouettes against the sky. The stars are brighter now. Inside, the habitat remains warm. The lights are dimmed. People are preparing for sleep. The systems continue their quiet work. Air moves through the ventilation system. Water is being recycled. The computers continue monitoring pressure. The greenhouse remains illuminated. Plants continue growing. Nothing dramatic is happening. And perhaps That is the most important part. A civilization does not become established through dramatic moments alone. It becomes established through ordinary nights, through people waking up, going to work, eating meals, teaching children, repairing machines, and going to sleep, then doing it again the next day. A settlement becomes permanent when tomorrow begins to feel ordinary. Perhaps one day, someone will wake up on Mars and not think about the fact that they are on another planet. They will simply open their eyes, get dressed, eat breakfast, go to work, come home, look outside, and see Mars. It will not feel extraordinary anymore. It will simply be home. And perhaps that is the quietest way humanity could conquer another world. Not by defeating it, not by changing it completely, not by making it look like Earth, but by learning how to live within it. Mars would remain cold, dry, dusty, red. Its atmosphere would remain thin. Its gravity would remain low. Its landscape would remain strange. Mars would never become Earth, and perhaps it would not need to. Maybe the future of humanity does not depend on finding another Earth. Maybe it depends on becoming capable of living in places that are not Earth. That is a much harder challenge, but perhaps it is also a more realistic one. Because the universe is filled with worlds that are different from ours. Some are frozen. Some are scorching. Some are covered in thick atmospheres. Some are hidden beneath ice. Some orbit stars, very different from the sun. If humanity ever becomes a truly spacefaring civilization, we will not be able to transform every world into a perfect copy of Earth. We will have to learn, adapt, build, and accept that each world has its own conditions. Mars could be the beginning of that lesson. A small island of life, on a planet that never promised to support us. And perhaps, late at night, when the work is finished, when the lights are dim, when everyone else has gone to sleep, someone will sit beside the window. They will look across the dark landscape, then upward toward the stars, and finally toward Earth. They may wonder how many people are looking back. They may wonder what humanity will become. They may wonder whether Mars will ever feel completely like home. But perhaps they will not need an answer, because for that moment, they are simply there, breathing, watching, living. The habitat continues quietly around them. The machines hum softly. The greenhouse lights glow in the distance. The stars remain above, and Mars, silent and immense, waits outside. Maybe Mars really does not need to become a second Earth. Maybe it only needs to become a place where a human being can close their eyes at the end of the day and feel safe enough to sleep. Outside, the red world remains silent. Inside, a small island of life continues, and somewhere beyond the horizon, the sun is already beginning its long journey toward another morning.